What was there before the beginning? Before the first spark of light tore through the darkness, before space stretched, before time took its first measured step? What truly existed? Imagine a silence so complete that even the concept of silence collapses. A stage without actors, an ocean without waves, a canvas untouched by color. Not emptiness as we know it, but a deeper absence, something beyond human comprehension. The mind struggles because even to imagine nothing, we must fill it with something, a void, a darkness, a stillness. Yet those are already creations, already definitions. The true silence before creation had no form, no shadow, not even the dimensions in which to contain them. And then comes the question that unsettles the human spirit. Was there ever truly nothing? Or was there always something hidden beneath the veil of eternity? Physicists wrestle with this paradox. Some suggest the universe emerged from a quantum fluctuation, a whisper of energy in the abyss. Others propose eternal cycles of birth and collapse where universes rise, die, and rise again. Perhaps there was no beginning at all, only an infinite horizon of existence stretching beyond imagination. The mystery is not only scientific, but profoundly human. To ask what came before the Big Bang is to confront the edge of knowledge, where mathematics dissolves into wonder, and where curiosity itself becomes the only light. Now, science dares to look behind the curtain of creation, and what it finds is both terrifying and beautiful, the silence before everything and the question that refuses to die. The silence of nothingness was broken not by a sound but by equations. In the early years of the 20th century, a quiet revolution stirred in the mind of Albert Einstein. With his general theory of relativity unveiled in 1915, he offered more than a theory of gravity. He revealed a stage upon which the cosmos itself could bend, twist, and flow. Space and time, no longer passive backdrops, were alive. They could stretch. They could curve. They could even collapse. Yet the beauty of Einstein's equations carried with them a troubling implication. They did not describe a still eternal universe. They whispered of motion, of expansion or contraction. The universe, according to mathematics, could not remain fixed. It had to evolve. Einstein resisted. He introduced a cosmological constant, a balancing term meant to steady the cosmos, to hold it motionless like a grand eternal cathedral. He sought order, symmetry, permanence, but the equations did not bend so easily to human preference. They contained within them a deeper truth, one that would be uncovered by others. It was Georges Lemaitre, a Belgian priest and physicist, who dared to take the mathematics at face value. In 1927, he proposed a radical vision. If the universe was expanding, then in the distant past it must have been smaller. If we rewound the clock far enough, all of existence would converge into what he called a primeval atom, a beginning point, dense and hot, from which everything unfurled. The idea was audacious. It challenged the comfort of eternity. It suggested that time itself had a birth, that the stars were not ageless but children of a cosmic fire. Many dismissed Lemaitre's vision as theological fancy, the imagination of a man of faith. Yet the universe would not stay silent for long. In the mountains of California, Edwin Hubble turned his telescope skyward. His work, patient and precise, revealed something astonishing. The galaxies were not fixed points scattered across the heavens. They were receding, rushing away from us in every direction. The more distant a galaxy, the faster it fled. The universe was expanding. Hubble's discovery, announced in 1929, struck like thunder across the halls of science. Suddenly, Lemaitre's idea no longer seemed like fantasy. The heavens themselves bore witness to a universe that once was smaller, denser, younger. The cosmos had a history and perhaps a beginning, but science demands more than possibility. It demands evidence. If a great cosmic fireball once erupted, then some trace of its heat must remain. Some whisper of that primordial furnace must still echo in the cold present. For decades, this remained a question unanswered, until a chance encounter on an antenna in New Jersey. In 1964, Arno Penzias and Robert Wilson were calibrating a radio telescope at Bell Labs. No matter how they adjusted their instruments, a faint background noise persisted, a hiss that seemed to come from every corner of the sky. They cleaned the antenna, even removing nesting pigeons, but the signal remained. It was faint but inescapable. What they had stumbled upon was nothing less than the afterglow of creation itself. The cosmic microwave background, radiation left over from the fireball that birthed the universe nearly 13.8 billion years ago. Not sound, not light in the ordinary sense, but a fossil of heat, stretched and cooled by billions of years of expansion. This discovery confirmed what theory had long suggested. The Big Bang was not an idea, not speculation, but reality. The universe was not eternal and unchanging. It was born, it grew, and it continued to expand. And yet, even as the pieces fell into place, the haunting question lingered. If the cosmos began with the Big Bang, what was before it? Did time itself awaken at that instant, or did it stretch into a hidden past we cannot yet see? Einstein's equations hinted that the fabric of reality may dissolve at the beginning, where density and energy grow infinite, where the laws of physics collapse into silence. Lemaitre's primeval atom could not tell us what lay before its own birth. Hubble's galaxies fleeing outward could only testify to motion, not to origins. And the afterglow of creation, though beautiful and profound, remained silent on the question of what preceded it. The first cracks in time had been revealed. The universe was no longer infinite and ageless. It had a story written in expansion, in radiation, in the whispers of mathematics. But the first chapter of that story carried within it an unsettling edge. A beginning demands a before, and in that before lies the deepest mystery of all. The discoveries of the 20th century gave humanity its first glimpse into creation. They unveiled a cosmos alive, restless, filled with history, but they also left the most haunting question unanswered. Was the Big Bang truly the beginning, or merely another doorway into something far older, far stranger, than the human mind has yet imagined? The curtain had lifted, if only slightly, and behind it was not clarity but shadow. At the heart of the Big Bang theory lies a silence deeper than the void itself. The silence of equations breaking, when the clock of the universe is wound backward. When galaxies collapse into the same infinitesimal point, a problem arises, one that unsettled the greatest minds of the 20th century. According to Einstein's general relativity, rewinding cosmic time does not simply reveal a denser and hotter universe. It leads to a singularity, a point of infinite density, infinite curvature, infinite energy. At time zero, the laws of physics do not merely stretch. They dissolve. Mathematics becomes meaningless. The universe reduced to a singularity escapes description altogether. This was the most profound shock of modern cosmology. If relativity is correct, then time itself has a boundary. Not a wall, not a frontier, but a point where the very concept of before loses meaning. The birth of the universe would not only mark the beginning of matter and energy, but of time itself. It was a notion that collided with both philosophy and common sense. How could time begin? How could existence erupt from non-existence? For centuries, philosophers debated whether the universe was eternal or created, but always within the framework of time as an unbroken river. Relativity suggested otherwise. The river itself may have had a source, and beyond that source, nothing. This troubled cosmologists deeply because science thrives on explanation. Every effect must have a cause, every event a precedent. But the singularity offered none. It stood like a curtain drawn across the deepest past, a place where observation and prediction failed. To confront the singularity was to confront the limits of human knowledge. Stephen Hawking, with characteristic boldness, once declared that asking what came before the Big Bang is as meaningless as asking what lies north of the North Pole. Time, he argued, is not infinite in both directions. It had a beginning just as the Earth has a surface. Beyond the North Pole there is no farther north. Beyond the Big Bang there is no earlier. It was a statement meant to quiet the paradox, to place a boundary around human questioning. Yet as the decades passed, cracks appeared in this logic. The singularity was not only a problem of relativity, it was a symptom of incompleteness. Einstein's equations described the large, the cosmic, the fabric of space and time as though it were smooth and continuous. But at the smallest scales, nature is governed by a different language, the quantum. Here, uncertainty rules. Particles flicker between states. Energy seethes with fluctuations. Space itself may be granular, woven from indivisible quanta. When relativity is pushed back to the first instant, it collides with quantum theory. Gravity curves space-time into a singularity, while quantum mechanics resists infinite compression, demanding uncertainty and fluctuation. The two great pillars of modern physics, so successful in their own domains, collapse into contradiction at the edge of time. This clash revealed something profound. The Big Bang was not simply a beginning. It was a boundary of knowledge. Relativity alone cannot describe it. Quantum theory alone cannot replace it. Together they cry out for a deeper framework, a unifying principle that might explain how space, time, energy, and uncertainty gave birth to the cosmos itself. The singularity became both a wall and an invitation. A wall because it halted the story at time zero. An invitation because it promised that beyond the failure of current theories lay a truer, richer understanding of creation. Physicists began to ask, what if the singularity is not the end of science but a signal? A signpost pointing toward new physics, toward ideas unimagined by Einstein or Hawking. Perhaps time did not begin absolutely. Perhaps the Big Bang was not the first event but the latest in an eternal cycle. Perhaps the universe did not emerge from nothing, but from a quantum sea where something, however strange, always existed. The shock of the singularity was not only scientific, it was existential. It forced humanity to confront the fragility of knowledge, the possibility that even the greatest theories may collapse at the edge of time. Yet within that collapse lies the hope of discovery. For if the singularity is not the final word, then what lies beyond it? The stage was set for new ideas, where relativity and quantum mechanics, enemies at the singularity, might one day converge into a single voice, a voice that could finally speak of what came before the beginning. The universe does not whisper in sound, but in light stretched thin across time. To uncover its first moments, humanity did not listen with ears, but with instruments tuned to the faintest radiation. The cosmic microwave background, discovered almost by accident, became a map, an ancient message painted across the heavens. But it was only the beginning. In 1989, NASA launched the Cosmic Background Explorer COBE. Its task was simple in description, but monumental in ambition, to measure with precision the afterglow of creation itself. COBE revealed that this radiation was astonishingly uniform, smooth across the sky to 1 part in 100,000. The heat of the young universe had spread like a perfect fog. But within that perfection lay something more subtle, tiny variations, faint ripples in the fabric of light. These fluctuations were not noise. They were the fingerprints of creation. Later missions sharpened the picture. The Wilkinson Microwave Anisotropy Probe, WMAP, launched in 2001, and the European Space Agency's Planck satellite in 2009, mapped the cosmic background with exquisite clarity. They revealed a universe only 380,000 years old, still glowing from its infancy. The patterns of hot and cold, barely perceptible, contained the seeds of everything. Every galaxy, every star, every planet, every life that would one day emerge, all were written in these faint imprints. These fluctuations hinted at an even deeper story. They suggested that the very first structures of the cosmos arose from quantum seeds. Minuscule fluctuations at the smallest scales had been stretched, magnified, written large across the universe itself. The vast cosmic web of galaxies was born from the restless uncertainty of the quantum world. Out of chaos came the scaffolding of order, but this alone was not enough. The smoothness of the cosmos, the flatness of space, the distribution of these primordial ripples, all demanded an explanation. How could the universe born in violence appear so uniform? How could regions of space so distant from one another share the same temperature, as though they had once been in contact? In the 1980s, a bold idea emerged. The universe, in its earliest fraction of a second, had undergone inflation, a moment when space itself expanded faster than the speed of light. In less than a heartbeat, the universe grew from subatomic to astronomical scales. This inflationary burst could explain the uniformity, stretching the cosmos smooth like a sheet of fabric pulled taut. It could explain the flatness of space, ironing out curvature into balance. And it could explain the origin of those faint ripples, magnifying quantum fluctuations into cosmic blueprints. Inflation transformed the picture of beginnings. The Big Bang was no longer a simple explosion. It was preceded by a mysterious engine that expanded reality with unimaginable force. The universe we see is not merely the product of fire and expansion, but of inflation sculpting its earliest form. Yet, as with every answer, a deeper question followed. What triggered inflation? What field or force drove this extraordinary expansion? Theories proposed exotic particles, fields of energy that filled the vacuum, decaying and releasing their power into space. But the mechanism remains elusive. Even now, no experiment has revealed the identity of this force. And more troubling still, If inflation occurred once, could it not occur again? Could it in fact be eternal? Some theories suggest that inflation never truly ends. Instead, it continues beyond our cosmic horizon, birthing countless universes in an endless multiverse. Our universe, then, may be only one bubble in an infinite froth, expanding within expansion, creation without end. If this is true, then the echoes we measure in the cosmic background are not only the story of our universe, but a fragment of something vastly larger. The question of what came before the Big Bang becomes entangled with a new paradox. If inflation gave birth to our cosmos, then what gave birth to inflation itself? Science in its precision maps the echoes of creation. Kobe, W. Mapp, and Planck have given us the most detailed portrait of the early universe humanity has ever known. But the portrait is also a riddle. The seeds of galaxies imprinted in quantum fluctuations tell us that the very large was born from the very small, yet they leave unanswered the most haunting mystery of all. Why did it begin at all? The echoes of creation are clear. They are written across the sky in patterns of ancient light. But as we listen more closely, we discover that behind every answer is a deeper silence, a silence that asks again and again, what lies beyond the beginning? The deeper science peers into the first instant, the stranger the story becomes. What began as a simple vision of expansion has unfolded into a labyrinth of paradoxes, where each discovery opens not a door of clarity, but a corridor of shadows. The universe, once imagined as a singular creation, now reveals hints of infinite beginnings. At the heart of this mystery lies a concept known as the false vacuum. In the quantum realm, even emptiness is restless. What appears to be nothing may hide potential energy, a field poised on the edge of transformation. Imagine a ball balanced precariously atop a hill. The false vacuum is that unstable height, a state that seems calm but is destined to collapse. When it does, it can release vast amounts of energy, fueling expansion on a scale beyond comprehension. Some cosmologists believe our universe itself was born from such a collapse. Inflation, that furious expansion of the infant cosmos, may have been ignited by a false vacuum decaying into a lower state of energy. In that moment, space erupted outward, carrying quantum fluctuations into the seeds of galaxies. The echo of that decay is the universe we inhabit. But the theory does not end there. For in the strange logic of quantum physics, a false vacuum does not collapse everywhere at once. In some regions it decays, releasing expansion. In others it lingers, persisting, inflating still. The result is staggering. Inflation may not have been a one-time event, but eternal. Regions of space continue to balloon outward even now, birthing new universes like bubbles in a cosmic sea. If this is true, then our universe is not unique. It is but one bubble among countless others, separated by vast expanses of inflating space. Each bubble may carry its own laws of physics, its own constants, perhaps even its own versions of reality. Some may collapse quickly, barren and cold. Others may endure, nurturing stars, galaxies, and life. Ours is simply the one we inhabit, one island in an unending archipelago of universes. This vision, known as the multiverse, is both breathtaking and unsettling. It dissolves the notion of a single creation into a boundless ocean of possibility. The Big Bang, once thought to mark the absolute beginning, becomes instead a local event, a birth within a larger eternity. Our cosmic dawn may be only one among infinite dawns playing out endlessly beyond our reach. And yet, with this expansion of imagination comes a deeper paradox. For if the universe is one bubble among many, then what is the sea that holds them? What is the eternal field that drives inflation without end? To solve the mystery of the beginning, science uncovers an infinity of beginnings, each raising new questions. Evidence supporting this possibility hides in the faintest details of the cosmic microwave background. Tiny anomalies, slight irregularities in the map of ancient light, may hint at collisions, shadows of other universes brushing against our own. Though not confirmed, these tantalizing patterns drive speculation. Could our bubble universe have neighbors, close yet forever unreachable? Could the afterglow of creation carry scars of encounters with worlds beyond imagination? The paradox grows heavier. With every advance, science explains more of how the universe we see came to be. The quantum fluctuations, the seeds of galaxies, the fury of inflation, all have become clearer. But the more precise the answers, the greater the mystery of what lies behind them. Inflation itself begs for a trigger. The false vacuum demands an origin. The multiverse demands a context. What came before? The question returns, unyielding, sharper than ever. Perhaps the greatest revelation is not that the universe began, but that it may never truly begin or end. Perhaps existence is not a single story, but a tapestry without borders, a sea of realities in which our cosmos is a fleeting wave rising and fading, while the ocean itself endures. For humanity, this vision is both liberating and humbling. Liberating because it suggests that creation is not a singular miracle, but a fundamental process of nature. Humbling because it places us in a cosmos vast beyond comprehension, where even the idea of everything is only part of something greater. The mystery deepens. Each discovery sharpens the edge of wonder. The more science reveals of the Big Bang, the more elusive its origin becomes. What once seemed like an ending point of knowledge now appears as an endless horizon, retreating as we advance. The universe has given us echoes, patterns, and hints, but behind them remains the haunting silence. The silence of what lies before beginnings, the silence of the infinite sea. The Big Bang, once thought to be the ultimate beginning, has become less of an origin story and more of a horizon of ignorance. Beyond it, science encounters silence. Yet human curiosity does not rest at boundaries. When the trail of evidence ends, imagination guided by mathematics reaches further, daring to peer into the shadows before time. One such vision arises from loop quantum cosmology. In this framework, space and time are not continuous fabrics but woven from discrete loops of geometry, like threads in a cosmic tapestry. At immense densities, the smooth flow of relativity breaks and the loops resist collapse. Instead of a singularity, the universe rebounds. Time does not begin, it bounces. Our Big Bang may have been the echo of a big crunch, the collapse of a previous cosmos reborn into expansion. If true, then history stretches endlessly in both directions, a cycle of contraction and rebirth, where universes fall and rise in a rhythm older than stars. Another speculation arises from string theory, a vision where the fundamental building blocks of reality are not particles but tiny vibrating strings. In this vast framework, entire dimensions beyond the familiar three may exist. Within them, immense membranes, or brains, float in higher dimensional space. Some cosmologists propose that our universe itself is one such brain, and the Big Bang was the fiery result of two brains colliding. In this view, creation is not the birth of something from nothing, but the crash of titanic structures hidden from our perception, each collision sparking a new cosmos. Stephen Hawking, together with James Hartley, offered a different window into the pre-bang. Their no-boundary proposal imagines the universe not as a line with a starting point, but as a curved surface with no edge. Just as the Earth has no edge where north begins, time itself may curve smoothly at the origin, eliminating the singularity. The universe in this vision has no sharp beginning. It simply is, emerging naturally from quantum laws, finite yet unbounded. Cyclic models take another path, suggesting the cosmos expands, slows, collapses, and expands again in an eternal heartbeat. In these models, the Big Bang was not unique, but one pulse in a cosmic rhythm stretching forever. Galaxies, stars, and life may all be temporary patterns, rising in one cycle, erased in collapse, reborn in another. The universe becomes a cosmic phoenix, burning, dying, and rising again endlessly. Still others push deeper into quantum genesis. In this picture, time itself may not exist in the way we understand. Instead, the universe could have emerged from fluctuations in a timeless quantum field. Just as particles appear and vanish in the vacuum, so too could entire universes emerge spontaneously, without cause, born from the restless energy of the quantum void. Our universe, then, would be a fluctuation vast enough to stabilize, to grow, to bloom into stars and life. Each of these ideas, loops, brains, no-boundary cycles, quantum genesis, attempts to do the same thing, to pierce the silence before the bang. They do not merely seek to explain what happened at the first instant, but to answer the deeper question of whether there ever was a first. Did time have a beginning, or is it eternal? Did our universe erupt from nothing, or from something hidden beyond sight? The answers remain elusive. None of these theories have yet been proven. Evidence is scarce, and the experiments that could confirm or deny them lie at the edge of possibility. Yet they endure, not as fantasy, but as reasoned attempts to reconcile relativity, quantum mechanics, and the mystery of creation. They are windows, fogged, incomplete, but offering glimpses of a reality stranger and deeper than human language can fully grasp. For now, the pre-bang remains a land of speculation. But the very act of asking, of daring to imagine, is itself a form of discovery. It reminds us that science is not only the pursuit of certainty, but the courage to face the unknown. The Big Bang may not be the beginning. It may be a bridge, and beyond that bridge the universe may hold secrets that even now wait for us to listen. The questions of origin are vast, but science does not answer them with philosophy alone. It reaches outward with instruments, building machines as large as cities and as delicate as whispers, to capture the faintest traces of beginnings. The search for what came before the Big Bang is not confined to thought. It is carved into mountains buried beneath ice, and launched beyond Earth's atmosphere. One of the most powerful tools in this search is the study of gravitational waves, ripples in the fabric of space-time, first predicted by Einstein and finally detected a century later by LIGO in 2015. These waves, born from cataclysms like colliding black holes, travel across the cosmos unimpeded. But scientists now ask whether even older ripples might exist, echoes from before the Big Bang itself. If the universe once passed through cycles, or if inflation roared with unimaginable energy, it could have left its mark in gravitational radiation. Observatories like LIGO, Virgo, and the planned LISA mission in space listen patiently for these ancient vibrations, hoping one day to capture a signature older than the universe we know. Above Earth, the James Webb Space Telescope peers deep into the past. Its golden mirrors unfold like petals, gathering light from galaxies so distant their glow began less than a few 100 million years after the Big Bang. In their shapes and distributions, cosmologists search for signs of the earliest conditions, clues of how structure emerged from quantum seeds. Webb's vision stretches nearly to the horizon of time, where galaxies shimmer on the threshold between the known cosmos and the unseeable before. On the ground, particle accelerators replicate the furnace of the early universe. At CERN's Large Hadron Collider, protons collide at energies once present microseconds after the Big Bang. In these collisions, matter and antimatter flash into existence, quarks bind into heavier particles, and fleeting states of energy emerge that may echo primordial physics. Each experiment seeks not only to confirm the standard model, but to glimpse beyond it, toward fields or forces that may have driven inflation, triggered symmetry breaking, or shaped the birth of space and time itself. Yet perhaps the most direct evidence of the early universe lies in the afterglow itself, the cosmic microwave background. Its patterns of temperature and polarization remain the most ancient fossil of creation. Within those patterns, scientists search for a delicate twist, B-mode polarization. This swirling signal, imprinted on the background radiation, would be the fingerprint of primordial gravitational waves, direct evidence of inflation's fury in the first instant. Experiments such as BICEP, Polar Bear, and the upcoming Lightbird mission strain to detect it, refining sensitivity to the faintest possible traces. A confirmed detection would not only support inflation, but open a window into energies far beyond what colliders on Earth can achieve. Every tool presses against the silence of the beginning. Gravitational wave detectors listen for vibrations older than stars. Telescopes capture light from the first galaxies. Accelerators recreate the inferno of the first microseconds. Satellite missions measure the sky with exquisite precision, mapping echoes written when the universe was still an infant. Together they form a chorus of instruments, each probing a different facet of the mystery. And yet the paradox remains. The closer humanity comes to the Big Bang, the more the question of before deepens. Even if inflation is confirmed, even if primordial waves are captured, the trigger of creation still hides. The instruments sharpen the picture, but beyond the picture is a horizon of unanswerable questions. Still, the pursuit endures. For science is not only a body of knowledge, but a practice of listening, a way of holding instruments to the sky and the earth, waiting for whispers that may alter the human understanding of everything. The tools of today may not yet reveal the pre-bang, but they mark the first steps in an endless journey, where each discovery leads not to closure but to wonder. The machines stand as monuments to curiosity, golden mirrors glinting in the cold of space, interferometers stretching for kilometers, measuring distortions smaller than an atom, colliders roaring beneath the soil of Europe, smashing matter into sparks of ancient energy. All of them reach for the same horizon, the silent curtain of creation. Perhaps one day their patience will be rewarded. Perhaps the sky itself will yield a whisper older than time, a signature from beyond the beginning. Until then, the search continues, relentless, a testament to the hunger of a species that will not stop asking, what lies before the dawn? Before the first light, before the first breath of space, there was silence. Not silence as we know it, but the silence of no time, no distance, no being. A gulf so absolute that even the word nothing is too much. Science has traced the universe back to its earliest fire, to the glowing embers of the Big Bang. It has mapped echoes left in ancient light, captured particles born in primal fury, and built machines to replay fragments of the first second. Yet at the very threshold where time itself begins, certainty dissolves. Theories offer glimpses, bold sketches of what might lie beyond that horizon. Loop quantum cosmology, brain collisions, cyclic rebirths, the no-boundary proposal, all strive to pierce the veil. Each vision illuminates a corner of the darkness, but none dispels it entirely. At the edge of time, mathematics bends into paradox and imagination strains against silence. Here, science reveals its own fragility. The universe does not yield every answer, not even to equations written in the language of stars. Beyond the Big Bang lies a frontier where knowledge falters. It is a reminder that even the greatest theories are human attempts to describe what may be beyond description. The gulf before time may never be fully bridged. Yet within that uncertainty lies something profound. For humanity, fragile and brief, has dared to ask the question at all. A species bound to a small world orbits an ordinary star, and yet it dares to probe the very birth of reality. Against the backdrop of eternity, this act itself is extraordinary. We are temporary, but our questions are eternal. To reflect on the cosmos is to reflect on mortality. Stars burn for billions of years, yet even they perish. Galaxies collide, universes expand, cycles collapse. Against these spans, human lives are brief flickers. And yet within these flickers, minds have risen that seek to understand the timeless. To ask what was before time is to hold the most fragile of candles against the deepest of shadows. Perhaps the answer is stranger than imagination allows. Perhaps before the Big Bang was not nothing, but a reality so alien that human thought cannot grasp it. Something beyond space, beyond causality, beyond even the language of existence. Theories suggest eternal inflation, quantum genesis, or universes before ours. But perhaps the truth is neither nothing nor something, but a state beyond both, a realm where the question itself dissolves, and still the question remains. It lingers like an echo in the silence of the cosmos, like a star whose light reaches us long after the star itself has died. What came before? What lies beyond beginnings? The universe offers no final answer, only the invitation to wonder. In the end, the search itself is part of the story. The attempt to reach beyond knowledge, to stretch imagination against the infinite, is what defines humanity. We are creatures of dust and starlight, bound by mortality yet dreaming of eternity. Our lives are brief, but our questions bridge billions of years. So the story does not close with certainty, but with mystery. Perhaps one day a new theory will illuminate the silence. Perhaps one day evidence will speak from beyond the horizon of time. But even if it never does, the search itself endures. The search is what makes us more than observers. It makes us participants in the grand story of the cosmos. And so the narrative fades not with answers, but with a call. The silence before creation still waits. The gulf beyond time still beckons, and humanity, fragile yet unyielding, will continue to dream of crossing it. For in seeking what came before time, we discover the essence of ourselves, beings who dare to ask questions older than the stars. The story continues, the search continues, and with it, the fragile, eternal flame of wonder.